Fluids may be classified in two different ways, either according to their behavior under the action of externally applied pressure or according to the effects produced by the action of shear stress. If the volume of an element of fluid is independent of its pressure and temperature, the fluid is said to be incompressible. If its volume changes, it is said to be compressible. No real fluid is completely incompressible, though liquids may generally be regarded as such when their flow is considered. Gases have a very much higher compressibility than liquids, and appreciable changes in volume may occur if the pressure or temperature is altered. However, if the percentage change in the pressure or in the absolute temperature is small, for practical purposes a gas may also be regarded as incompressible. Thus, in practice, volume changes are likely to be important only when the pressure or temperature of a gas changes by a large proportion. The relation between pressure, temperature, and volume of a real gas is generally complex though. Except at very high pressures, the behavior of gases approximates to that of the ideal gas, for which the volume of a given mass is inversely proportional to the pressure and directly proportional to the absolute temperature. At high pressures, and when pressure changes are large, however, there may be appreciable deviations from this law, and an approximate equation of state must then be used. The behavior of a fluid under the action of shear stress is important in that it determines the way in which it will flow. The most important physical property affecting the stress distribution within the fluid is its viscosity. For a gas, the viscosity is low, and even at high rates of shear, the viscous stresses are small. Under such conditions, the gas approximates in its behavior to an inviscid fluid. In many problems involving the flow of a gas or a liquid, the viscous stresses are important and give rise to appreciable velocity gradients within the fluid, and dissipation of energy occurs as a result of the frictional forces set up. In gases and in most pure liquids, the ratio of the shear stress to the rate of shear is constant and equal to the viscosity of the fluid. These fluids are said to be Newtonian in their behavior. However, in some liquids, particularly those containing a second phase in suspension, the ratio is not constant, and the apparent viscosity of the fluid is a function of the rate of shear. The fluid is then said to be non-Newtonian and to exhibit rheological properties.